In this video, we're going to learn about trig functions and the unit circle. So what does that even mean? I'm going to use my unit circle to evaluate all 6 of my trig functions. So sine, cosine, tangent, cosecant, secant, cotangent. And I'm going to use both degrees and radians and even positive and negative values on my unit circle, as well as values that are larger than 360 or 2 pi and that are negative. So I can learn and use my unit circle to evaluate all of those things. So I've drawn out a unit circle for you, and I've included basically everything that you would need to know on the unit circle. I just wanted to do a teeny tiny quick review. So all the dots, we're going to start with degrees, by the way. All the dots that are pink are, you count by 30 degrees. So 0, 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, 360. All the orange dots, when you go around the unit circle, you count by 45 degrees. 0, 45, 90, 135, 180, 225, 270, 315, 360. Then when we go on radians, and radians are on the outside, radians, the pink dots, count by pi over 6. So 0, pi over 6, 2 pi over 6. Notice I've written these in reduced fraction form. 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, 12 pi over 6. And the orange dots count by pi over 4. 0, pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, or 2 pi. I've also included in here this all sine, tangent, and cosine. I remember this as all students take calculus. That's how I learned it. Where the A stands for all, the S stands for sine, the T stands for tangent, and the C stands for cosine. And what does that tell you? That tells you what values are positive in your unit circle. And remember that your ordered pairs, these guys down here, the x value represents the cosine of your angle, and the the y represents the sine of your angle. And so these values, A, S, T, C, are going to let you know which if your x value is positive or your y value is positive. I've also included my first quadrant of ordered pairs, which we get from special right triangles, which I'm not going to go into in this video. But this is all I need to know in order to figure out everything else in the unit circle, because I can use properties of reflection to find the rest of the points. So for example, I know right here at 60 degrees or pi over 3, if I reflect it over to 2 pi over 3, I have my same ordered pairs. So this is going to be 1/2 square root of 3 over 2. However, my sine value is going to be positive, which means this is going to be negative 1/2 square root of 3 over 2, which makes sense because I'd have to go left, which is negative, and then up, which is positive. So I'm going to use my unit circle to do that. If I know all the tricks, if I know how to count, the pattern, count by pi over 6 or count by pi over 4, which values in which quadrants, which values are positive, I can use this unit circle to evaluate pretty much anything. But when I do my unit circle problems, I don't ever write all of this information out. Okay, I do this. I write a teeny tiny unit circle like this. I don't even really make it this neat, actually, when I do my problems. So I know this is the point 1, 0, and this is the point 0, 1. I know this is negative 1, 0, and 0, negative 1. And then I count to 4. Check this out. So I start at 0. I'm going to start up here, and we're going to kind of go in a rainbow down for my x values. And then we're going to go in a rainbow up for my y values. So my x values, I start up here at 90 degrees, and I count 0, 1, 2, 3, and I'm going to write the 4 here. Then for my y values, this purple, I'm going to count 0, 1, 2, 3, and I'm going to write the 4 up here. Okay, so I'm going to divide everything by 2. and I square root the tops of everything. And what do I end up with? Square root of 4 is 2. 2 divided by 2 is 1. I get 1. Square root of 0 is 0. 0 divided by 2 is 2. So I get the 0.10. Then I get square root of 3 over 2 and 1/2 because the square root of 1 is 1. Square root of 2 over 2, square root of 2 over 2. 1/2 square root of 3 over 2, and then this reduces to the 0.01. So if I can remember that trick, when I do my problems, that's how I do the unit circle. And then I just count from there to figure out what I'm going to find and where on my unit circle I need to go to use my ordered pairs to find whatever trig function they're asking me. So I have a couple examples for you. I just wanted to write on here that you can find all 6 trig functions from just sine and cosine. And I always had a hard time remembering like which value, is it secant or cosecant, that matches with sine and vice versa. So I always remember that S matches with C. S with C. Let me try that again. S matches with C. So if I have sine, I know that cosecant is going to be the reciprocal. Okay, if I have cosine, I know that secant is going to be my reciprocal. And cotangent and tangent are the easy ones to obviously pick out. Okay, so let's get started. All right, so I want sine of 5 pi over 3. So I don't have my unit circle drawn, so I'm literally going to go ahead. I'm going to draw my unit circle. Like I said, I don't make this very neat. So this is going to be 1, 0. This is 0, 1, and I count 0, 1, 2, 3, and 0, 1, 2, 3. I don't even do the divided by 2's and the square roots because I know what that means. Okay, so 5 pi over 3. So I'm going to count. So I'm doing radians. So I'm going to put all my dots in. Actually, we'll just do it highlighter because it's easier that way. So we'll do pink like we did before. And orange. Okay. So we're going 5 pi over 3. Pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. Sorry, 0 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6. 10 pi over 6 is going to give me 5 pi over 3. So I'm here. This is where I'm at. So I'm going to use these points here. Means that this point right here is going to be 1/2 square root of 3 over 2. And if all students take calculus, my cosine value is positive, which means my x value is positive, my y value is negative. So the sine of 5 pi over 3 is going to be my y value, or negative square root of 3 over 2. Okay, cosine of negative 225. All right, so 225, if you want, you can come back up here and you can look. All right, 225 is the same as 5 pi over 4, or you can count it on your way out. And you can always use the unit circle while you're doing these problems. So 5 pi over 4 is right here, which is the same as 225. But look, it wants negative 225. So if I'm going negative 225, I have to, so look at where I am. So I counted, normally we go around the unit circle 1, 2, 3, 4, 5. But I have to go backwards. Now I'm going in the negative direction, so I'm going 1. So this is negative pi over 4, negative 2 pi over 4, negative 3 pi over 4, negative 4 pi over 4, negative 5 pi over 4 is right here. So negative 5 pi over 4, I'm going to write in my values. This is square root of 2 over 2, square root of 2 over 2. My sign is positive, which means my x value is going to be negative. So the cosine is going to be negative square root of 2 over 2. Okay, tangent of 5 pi over 4. Well, we just found 5 pi over 4, kind of, because we did the negative of it. So 5 pi over 4 is the same as 225 degrees. You can come back up here and look if you need to. Like I said, and you can always count. Okay, so 5 pi over 4, I always just count. Here I am. Come on, laser. So I'm at 0, pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. I'm right here. Okay, so I'm going to write this out. Right here, this is a pi over 4 value. These are all the same. These are the square root of 2 over 2, square root of 2 over 2. Tangent. If tangent is positive, that means that both my x and y values are negative because the negative divided by a negative is a positive. So tangent of 5 pi over 4. Okay, now I had to figure this out. Literally, I have to take my values and divide them. So I take negative square root of 2 over 2 divided by negative square root of 2 over 2. Anything divided by itself is equal to 1. So this is going to be equal to 1. Okay, next, cosecant of 2 pi over 3. Okay, so I have to find 2 pi over 3. So I find 2 pi over 3. So this is where I'm going to count by pi over 6. So 0, pi over 6, 2 pi over 6, nope, 3 pi over 6, that's pi over 2. 4 pi over 6 is 2 pi over 3. So I'm here. Okay. Now, I have to find my values. So this is the value 1/2 square root of 3 over 2. I know that because it's the same as this value. I reflected it over. My sine value is positive, so this is going to be negative. Now cosecant, remember C matches with S. So cosecant is going to match with sine. It's the reciprocal of sine. So if sine is square root of 3 over 2, then cosecant is just going to be the flip of it, 2 over square root of 3. But no square roots in the denominator, so you have to rationalize. So I'm going to multiply the top and the bottom by the square root of 3. I call it a fancy version of 1. Okay, square root of 3 over square root of 3 is the same as 1. So I'm not changing my problem, but I'm just putting a mask on it. I'm making it look different. So I multiply by my fancy 1. This gives 2 times the square root of 3 over 3. Final answer. Sorry, that's a funny looking square root. Let me try that again. There we go. Okay, next. My unit circle is getting a little crowded here. I think we'll be okay with this next one. So cotangent of pi. All right, pi is an easy one to find. Pi is right here. Pi is the same as 180 halfway around my circle. So I'm right here. At pi, I'm at -1, 0. Okay. Now, we know that tangent is sine over cosine. So cotangent is going to be cosine over sine. All right, my cosine value is -1. My sine value is 0. You can't divide by 0. It's totally not allowed. So what does this equal? Undefined. Okay. Okay, last one. Secant of 540 degrees. So I'm literally just going to go around my unit circle and count until I get 540 degrees. The alternative is you could take away 360. You could say, okay, because this is over, because it's over 360, I can say 540 and I can take away 360, and that gives me the same as 180. I could also literally just count around my unit circle if you didn't have a calculator handy, or you just say, okay, I'm at 360s all the way around, and then I'm going to count by 30 degrees. 360, 390, 410, 440, and go around that way, okay? So I like to, it doesn't really matter how you choose to do it, but I like to just subtract from 360. So I did 540 minus 360, and I got 180. So I know it's the same as 180 degrees, I guess is my point. I'm just going around the circle. You just keep going around the circle using the same pattern. So secant of 180 degrees. So this is the same as the secant of 180 degrees. Okay, so S matches with C. So secant is going to match with cosine. All right, and the cosine of 180, we just used 180 degrees, is right here. So I take the reciprocal of -1, which is -1. All right. If you have any questions, let me know how the unit circle works, how to find your other 3 trig functions, so the secant, cosecant, cotangent. Those are probably the harder of the 3 to find from the unit circle. If you have any questions, please let me know, or I can give you some more examples if you need it. Good luck.